It's a really easy question.
I think what we're talking about is what's at the very edge.
Hey everyone, it's David Kosloski with the Edge Tech Podcast. Today we are currently at Platform, and I do apologize, I've lost my voice. However, I am here next to Shane Rogers, the IT Director at Harrison Steel. Shane, thanks so much for being here today.
My pleasure. Looking forward to having a conversation.
I hope you can hear me this far away.
I can hear you just fine.
It's a bummer. I promise I wasn't out partying last night. I went to bed at like 9:30. I just, for whatever reason, lost my voice.
It happens. I get it. Too much talking.
Yeah, right. Yeah. So, look, you've got a lot of use cases at Harrison Steel, so I'll let you do most of the talking here. But I wanted to know, how are you guys using, or first off, what do you guys do? Let's start with that.
So we're a steel foundry. So we make parts for the mining industry. So things from like 400 pounds all the way up to like 22,000 pounds. I mean, so big parts, big facility. In about 900,000 square feet under roof. We've been around since 1906. So we're old school manufacturing. So family owned since day one. So
nice. Where's it located?
Attica, Indiana, a little teeny town. If you blink, you may miss it, but other than the 2 stoplights, it will slow you down.
Crazy. So you guys are very well known in the community.
Yes, we have been there. I mean, it's a company town. I mean, they built a town kind of around the company. So
that's wild. That's really cool. So compute. How does a foundry utilize compute?
Wow. Yeah, that's, you go back 30, 40 years ago and it wasn't a thing, right? I mean, everything was manufacturing. We did it all old school, all by hand. And then, the data side of driven, making decisions. They learned over time that you can't make good decisions without having good data. So now we have data that it dates back since I started there 30 years ago. So we still use the same data that we had. Simple things like recipes for understanding what chemistries to do for metals. How long does this metal need to stay in a furnace to get a certain level of hardness, So that's the early stages of our compute. And then it starts moving forward as we're now in the robotics. Now we're into machine tools that are all doing everything now is all driven through the compute stages. So it's the evolution that we've had has been amazing. So
when you talk about the robotics and the compute that you guys are using, how many compute devices do you think you have within the foundry?
Well, if you count like all of our PLCs that run all of our machine tools, I mean, there would be thousands.
Oh, okay.
Yeah.
From an edge computing perspective, can you kind of just list a couple examples of the macro topics, if you will?
Yeah. So from the edge state, we do a lot of collection of that data, right? So all these PLCs they have hundreds of thousands of endpoints of data collection on PLCs. So we're using our edge compute to grab all that data and collect it at the edge. That way we don't have to worry about having it move across the network or have it readily available to the end users. They can see it on a screen then from the edge device. So that's where we started with edge. We have a lot more ideas of where we want to go with edge as a time comes. But
what kind of data are you pulling? Sorry.
So it's PLC data. So it's like ones and zeros, but more like say temperatures, humidity, so sand flow, all these things that you think about when you think about big machine tools, right? And so we have sand flowing into molds, and these molds, we need to know how fast that sand goes in that mold. So we have all this data being collected to determine how fast that stuff is happening.
What has that done for the company versus the old ways?
Well, it gives us ways of starting to track maybe quality issues. Now we can go back and we go back in time and say, oh, we had a problem with that part. Why did we have a problem with that part? And let's go back and look at the data now and say, humidity was bad that day. Was that the reason? Or we have, that sand flow was not exactly the way it should. Did it run, 33.3 seconds worth of sand? Did that happen? So we can see that now.
That's crazy. So is it all quality based, or is there other?
First initial run was quality based, right? We wanted to see what happened with quality. Now we are looking at other things. Now we're looking at labor based stuff. How long is this labor doing welding on something? Now we're looking at, how long is the electricity running? So now we can look at cost analysis. So we're looking at a lot of other areas right now.
And how are you doing that exactly?
So those are new tools that we're looking at, trying to actually design these, because there's nothing out there to really do this. So we're looking at it from commercial grade testers or voltage meters to then watch the voltage of the welder, see what he's doing. And then that data is being collected at the edge.
That's crazy. Are you using one single compute device to kind of power all of these, or is it?
No, we have multiple locations in our facility with edge NUCs at there.
So you're running.
So right now we have 6.
Okay, cool.
Yeah.
And then, yeah, like, so it sounds like a lot of this data helps from a quality control perspective. You're starting to kind of tap into this other area, which means that you're innovating, right? So what else do you have on the roadmap where you're like, I'd love to do this?
Well, I think AI is the next stage, right? Or at least machine learning, so we can start really making decisions without having to. Right now, it's all BI, right? It's all business intelligence, so we're going back and doing it after the fact. We need to move to the next stages where it's making decisions for us. So if something doesn't go right, we need to have it ping out, send out to the engineers, say, hey, look, you need to be watching this in the next 30 days, So we start having that level of AI working for us instead of us doing the work for it.
What about safety? Is that ever a concern?
Yeah. So we do have cameras throughout our facility. Safety is a big concern. I mean, we have, that's number one by far. And, we have our quality metrics, and people is the number one quality metric that we keep eye on. So safety is absolutely a big deal. And I would like to see us do more with the cameras, more vision learning, but it's at this stage our facility is hard to do that with the size of it. So
yeah, I mean, you're also in an extreme environment, right?
that's the other side of that.
Yeah. So what kind of challenges does that face for you?
Well, I mean, it's just overheating things like crazy. We have micro dust, which has got metal flakes in it. So that's flowing through the air all the time. So as that builds up on equipment, it actually starts shorting things out. So it's amazing on how dirty the environment really is. It's a foundry. You have dust, you just see it in the air as you're walking through. So
yeah. And then from a heat perspective, like what have you found to be successful and not successful?
Well, I wish I could have a good answer there because I don't, because things go down all the time because of, just overheating. I really need more ruggedized equipment, and that's where I'm going towards the future is true ruggedized edge equipment, where the NUC is great. It works amazing, but it does still come to a heating issue at times.
Yeah. If you had one thing that you're like, if I could implement this tomorrow, it's going to save the company money or it's going to increase safety or what have you, what would it be?
Oh, I mean, I would replace I would put a lot more edge out there and start really replacing the people side of things and do more automation. I mean, I think that's where we need to get to, stop working on all we stare at data. We have data analysts that stare at data all day long. Why are they staring at all that data when we should be able to help them out with automation?
Sure.
Yeah. So we're still this mentality of all of our stuff has to be old school because we're old school manufacturing. So, that the idea of the robots, the things that we're looking at to start automating more of our workforce, we need to get into that a lot more.
But that automation doesn't necessarily replace the person.
It doesn't necessarily replace the person.
It means that there's like a human in the loop type of thing. Yes.
Yeah. So we're going down that route, and we're doing vision now with our robots. So they're doing vision control with edge device compute. So right there, it's doing all the cutting of the welding or the flame washing now where a person doesn't have to do it, but that person's still there watching, right? We didn't lose that person. Like you said, we're not losing the people. We're just manipulating them a little differently in their job. So
yeah, more quality control, making sure that's doing its job. Yeah, that's fair.
Yeah.
That's good. Are you building a lot of this stuff yourself? It sounds like you said you're like, I did this. Like that seems way more involved than most IT directors.
So yeah, it is really. I mean, that's the things that we're doing. We're not out there. That's not available on the market. So we're building these ideas and making them happen. So, I mean, our edge collection that we're using with the NUC, I mean, no one had ever done that before. We came up with the idea of how to use, and they told me the software we were using couldn't be done, but we figured out how to do it and, and made it work.
That's awesome.
Yeah.
That's great. Well, I'm excited to hear more. I hope to visit Harrison Steel and kind of see what you guys are doing there. Maybe do another podcast where I don't sound like absolutely awful.
You can listen to all the work outside in the plant. That'd be a lot harder here.
Yeah, that's awesome. Shane, thanks so much for hanging out with us for a little bit and talking about what you do. And thank you everyone for listening to the Edge Tech podcast. Again, I'm David Kosloski. See you soon.